Okay, ma'am, you start the session, ma'am.
Okay, thank you.
Ma'am, just
Um,
wait, ma'am. After giving introduction, you can start, ma'am.
Certainly.
Okay.
Okay, I'll wait.
Good evening to everyone in this forum. I am Satya Sudha. I am very glad to welcome you all for today's fifth day of our 6 days online FDP on innovative medical healthcare in AR/VR. Today we are having our chief guest Dr. Logeshwari Nallathambi, and she is the NHS hematologist at Kingston Hospital, London. And he is also a founder and CEO of our local online for women, and she is the public health advocate, healthcare digital marketing, and women business support. And she has completed her MBBS in medicine and surgery from Tamil Nadu, Dr. MGR Medical University, Chennai during 1997, and did her MRCP in general medicine from Royal College of Physicians, London in 2005, and completed her FRC path hematology from Royal College of Pathologists, London in 2016. And she has worked as a medical SHO in West Cumberland Hospital for 2 years, and also worked in Worthing Hospital as a SHO, acute and general medicine for 6 months. And she worked as a trust doctor, hemato-oncology at Princess Royal University Hospital over 2 years. And also she worked as a specialist registrar in hematology at King's College Hospital, London for 8 years. And now she is working as a consultant hematologist uh, in Kingston Hospital, London, and she has over 20 years of experience in medical field. And also, she is a social entrepreneur, encouraging the social entrepreneurship for women, and also interested in graphic design. And she's the founder and CEO of our local online for women, and she has honored with the Inspiring Humanitarian Award, and such a eminent personality is with us. I'm welcome you, ma'am.
Thank you very much, Sudha. You
Thank
reminded me of my journey. It felt like I took myself back to my younger days and then walked towards today. Thank you very much
This
for
is
that
one
beautiful
in
introduction.
short, and ma'am, you have did a lot of things, and you have helped many women, and you are encouraging women entrepreneurs.
Yeah, I think certainly I will tell you all about it. That's something very dear to me, Sudha. And
Okay, ma'am.
first, and thank you very much for having me here and for this beautiful introduction. And
Thanks,
thank
ma'am.
you to
We welcome you, ma'am.
thank you very much. Thank you.
Thank
Um, and thank you to Professor Uma Maheshwari. And I can see behind the scenes how much effort she has taken to organize this. And that too, a session for like 5 to 7 days. That's a lot to organize. And I hope I can add some value from my expertise of medical world. And now, Satya Sudha talked about my journey, which is exactly who I am. I'm Dr. Logeshwari Jayaraj Nalathambi. See, I come from Tuticorin, and I studied at Madurai Medical College, and that was a fantastic time. And from there, I came to England to do MRCP, and then I did FRC Path, which is Fellow of Royal College of Pathologists, and I specialized in hematology. So I don't know how many of you know in depth about hematology. It's a blood disorders and blood cancer specialty, a very intense specialty. And I had the opportunity to study this at King's College Hospital, which is a very well established big institution in London. I consider myself, lucky to be blessed with that privilege of being with some extraordinary minds I met there. People with extraordinary knowledge and who are ready to, find new treatments for some rare disorders that probably many of us wouldn't have even heard the name of. So after working at King's, I also worked as a trained at King's. Then I worked as a consultant at East Surrey Hospital. From there, I in fact took a completely different turn into the business world. Into the business world, I do two things. One is I have a startup in India, mainly to focus on prevention. Like, I must say that the biggest war nowadays we fight is not that we see in Ukraine or in Israel. It's within ourselves. It's diabetes and obesity. That's the major killers in this world. Many of things that we could prevent. Treatment, what we are going to talk today, is very fascinating. And they are focused mainly on treating the diseases that we all come across. But more than anything, prevention is better than cure. I'm a firm believer of this. And that's why I started a startup called Wellbe in India, focused on weight loss, treating obesity, and the metabolic disorders. Then, as Satyasudha said, I'm a keen passion, enthusiast to support women. I come from a family of women who are doctors and who has empowered many women to do better. And before we start, I would like to tell you all about what I do in this area, to keep it a bit more lighthearted before we step into a serious technology talk. Now, many women, as you have joined here, would agree that it's a different challenge when we take a professional role for women. The work-life balance get tough. And I know many women who give up job, who give up working simply because they can't, face the pressure of work and their personal commitments. On the other hand, there are women who unfortunately don't get the opportunity to go to universities or college. But I must say, all these women have some extraordinary skill sets that never gets comes to life. And there are also women who are in a very keen, very important position. Like, I have a lady who is a vice president of a company, but she tells me that she loves arts. She's a very good, artist. And now she has set up a business and she does both art and she's also a vice president. And same way, retirement. After retirement, many women, especially in arts, creativity, photography, wellness, fitness, and even cooking, knitting, and there are certain skill sets that women love to do. So what I do in this organization called Role of Women is, how do we help women to establish a business and stay financially independent? Because I am sure all of you here are very clever people here who have joined and who are blessed with an opportunity to stay financially strong and independent. But not many women are, including in the UK. The organization is not just for India. There are Africans, there are British people there, British ladies, and many of them who have not had the opportunity like how we all are blessed with. So I help them, mainly focused on. Now, here's what the technology, today we are talking about technology in healthcare. But I must say, technology has the power to transform simple lives. That's what fascinates me the most. And for example, I have a 72-year-old lady. Do you believe this? There is no age limit to do business. And a 72-year-old lady who is a NHS secretary worked in National Health Service. And this lady wants to do greeting cards. And she is a member of our organization. What she does is she has to buy the paperwork and the designs for making cards. And she doesn't make much out of this in a business anyway. She earns very little. She sells it for very cheaply. But then we taught her to do digital designing using a free tool called Canva. Now this lady amazingly designs beautiful cards for no great investment, and that has transformed her life. I know her sitting in markets, okay, not even able to sell, to a very beautiful way of selling via social media, and that's the transformation. We are more focused on teaching digital media, online presence, and helping women to establish business. This why I've explained this is how I came into a bit of a technology. I'm not a hugely tech person, but then to teach these women to do digital marketing, I thought I myself have to learn it. So in fact, I went to London Business School. I studied digital marketing, and so that I could teach these women and also use it for various purposes. And I also do currently doing AI in healthcare with Stanford University, which I'm yet to complete. So that's my journey into a partly digital world. And I think enough about me. I've told a lot about me. And so coming to today's topic, the it's a very fascinating topic. I'm sure you, as much as it is fascinating for you all who are technology experts, I must say it's very fascinating to the medical professionals as well. How is the future of our healthcare going to be? It applies to every one of us because we all are heading towards that future, and our children are going to live in that future. Now, I must say, interestingly, in Tamil Nadu, when we bless couples or young people, 100 வயசு வரைக்கும் வாழுங்க அப்படின்னு சொல்லி நம்ம bless பண்ணுவோம். Nowadays, when I do that, I question myself. Why? I think the younger generation might live longer than 100 years. That's the fascination we are entering into. So இப்பெல்லாம் when I bless, I don't use that term. I just say live long and healthy. Why? Certainly the age of living has improved. Currently in UK, people live up to 85 years, and in India we have a longer lifespan as well. Not only that, we are trying to reverse the aging process. There are certain conditions where we can use treatment and be able to reverse the damage that's been done to the body. And also the quality of life. Living with diabetes or cholesterol has been, made possible. Like my daddy, he was diagnosed with diabetes when he was 32. He's now 82. He has managed with all the medications, but I must say my family takes care of him with regular checks and lifestyle changes, but he's managed to live a very good life over 50 years with diabetes. And this will keep on improving with newer drugs and innovations happening. Now, having talked about, let me share the slides that I've done. Let me see. Please stop me if you have any questions in between. Can you all see the slides?
Yes, ma'am. Yes, ma'am.
Thank you. Let me see. I don't know. Should I go there? Is this better?
Yes, ma'am.
Okay, thank you. I'll carry on now. Now, we talked about the exciting increased longevity and quality, and even reversing damages and aging. Now, if you ask me what has made this possible over these years, the first important thing, I think the key change the difference is our understanding of the human body. It has gone enormously deep. For example, let me talk about the specialty from where I come from, the blood specialty, because that's one thing that you all would have seen. If I talk about liver, probably many of you wouldn't have seen it, but blood, we all have seen with our own eyes. We know how it looks. That's the understanding what we call as anatomy. Anatomy is the macro appearance of a human body. Now, secondly, our understanding of microscopic appearance, the histology, is very clear over the last probably 70-80 years. We have a deeper understanding. For example, in the blood, if you put it under the microscope, you can see the red blood cells, the white blood cells, platelets, and there are proteins, with majority of the blood being water. So that's the microscopic composition of blood. This understanding we know for years. But what is fascinating for current world is we understand in depth how every cell, the red blood cell, the white blood cell, how do they function? What are those cell signals that happen inside the red blood cell? For example, there is a hormone called erythropoietin. Erythropoietin is produced by our kidneys. As the name suggests, erythropoietin means erythro is red blood cell, poietin is a growth factor. It's a red blood cell stimulating growth factor produced by the kidneys. And what do these hormones do? They go and act on the bone marrow cells where our red blood cells are produced. Now, what happens when this erythropoietin goes and touches the cell surface of bone marrow? There is an interesting cellular pathway that gets activated called as JAK2 STAT5 pathway. These words might seem, not very easily comprehensible, but I will try to explain. JAK2 is Janus kinase pathway. Now, this pathway is a cellular growth pathway. This signals inside the cells then get carried away to the DNA. And it tells the DNA, phosphorylates the DNA to say, can you untangle that particular part of you where you can produce red blood cell? That's how they communicate. This is how erythropoietin communicates to the DNA through the JAK2 kinase STAT5 pathway. And then DNA unfolds and red blood cells are produced. Now, this in-depth understanding has given some enormous, fantastic innovations as well. For example, many of you, you might have heard the word anemia. Especially in India, women have iron deficiency anemia. Anemia means you have reduced red blood cells. But in hematology, we deal with conditions where more red blood cells are there. That's also not good. Having too much of red blood cell also impacts us. So in such conditions, what we call as myeloproliferative neoplasms, there is a drug that is specifically targeted at this pathway, which is JAK2 STAT5 pathway, called ruxolitinib. Now, this drug can stop this cellular signal, telling DNA to reduce the production of red blood cells. Isn't this, amazing? So this is one example, and there are many examples I can give from hematology where the drugs are being produced towards the cellular signals. In fact, a drug that has changed the life completely of one of the blood cancer called chronic myeloid leukemia is in fact called as a golden bullet, called imatinib, which has completely, normalized this leukemia from which, like 15 years ago, most of them were dying from it. Similarly, so our understanding of human body is the key thing for this change, this fascinating change that we all are heading to. Now, on top of this is like having a very skilled person. If you give, like someone who can create a sculpture, if you give the best tools to him, he can produce the beautiful artwork of lifetime. Same way, why at the time when we have the deepest understanding of the medical world, technology has given us beautiful tools to carve this into treatments and diagnostics that can be, precise and help us to detect diseases early. Now, there are many technologies. I'm sure you all have been listening to AI and augmented and virtual reality. On top of this, there are gene editing technology, nanotechnology, and there are reversing technologies, and gene sequencing technologies, technologies for drug invention. And there's so many things that has come up aiding us to for a better cure for the human illnesses. And subsequent to this, now we have to deal with a different population and different illnesses. Obviously, aging population is increasing, and none of this, like ruxolitinib or rituximab or imatinib, they're not going to come out cheap like a paracetamol or an ibuprofen that you can buy over the counter. It's not going to be like that. They're going to be expensive, and we need to be mindful. Whatever invention that happens, will it serve the entire humanity? Well, that's one question and a problem that we all have to face as more things come up. And also with AI, one thing that worries me at all time is the speed with which things come. Are we capable enough to keep up to date? And those are the challenges. But put aside those challenges for today, and we'll talk about what are those fantastic things and the benefits that technology can bring to us. I'm trying to change my screen. Okay, here. So to begin with, our first thing is I want to talk about about personalized medicine. Many of you might wonder, what is this? It's like if we have only one size shoe in this world, okay, not all of us. So for some of us it's going to be big, for some of us it's going to be small, for some of us it will fit, some of us it can scratch our feet. And the same way medicine as well. Could it be one treatment for all? It's a question that has arisen in the modern era. Why we ask this question is, we all are very different people. We have a different genetic makeup. Our lifestyle is different. The environmental exposure is very different. And our mindset is very different. The everyday stress that you and me go through is very different. And our gut health, the bacteria, the microbiology, the microbiomes that live in our gut, that has a huge role in our health, is very, very widely different. While this is the case, can all the treatment that we prescribe, is it like, may not be the right one for everyone? This will change in future. Has it changed now? To a little bit. For example, in cancer treatment, in breast cancer, after completion of the chemotherapy, we can predict what hormone receptors are being expressed by the breast cancer cells. And the treatment is given only when that type of receptor is expressed by the cancer. For example, there is a receptor called HER2. HER2, if it is positive, then the patient gets what is called as Herceptin. It's a monoclonal antibody targeted towards this receptor. It's called trastuzumab. So this is a type of precision medicine. Instead of giving Herceptin to every breast cancer patient, we have ways of finding out who has the HER2 transformation, and we give the drug only to them. Now, this is quite straightforward, isn't it? When I explained, yes, it's HER2, positive or negative, it's as simple as that. But there are more complicated scenarios. For example, let's take obesity. Obesity is always thought like, oh, somebody is food addicted. Is that so? Or is it more than to it? definitely more to it. Why some people are more prone towards obesity. It's not only genetic, but also certainly even when you say the food habits, why someone wants to eat more and why someone wants to eat less. Is it habit, or is it also driven by our body makeup, or is it certainly to do with hormonal makeup? Is that dependent on the genes, or is it also up to the financial status, or is it up to the environmental trigger? And more than that, mind. I always talk about mind. People neglect their mind, because whenever we talk about mind, people think we are weak, but that's not the truth. Our body and mind are deeply interconnected. The mind even signals our immune system. So is it how much of that mindset becomes an emotional eating, and what contributes to obesity? Now let me say, if we collect, it's so easy to collect these details, okay, from like 100,000 people. We collect the data, analyzing 100,000 people for obesity in varieties of, like, if we take like 50 variations and we have to analyze, that's going to take a long time. Now, why I say this is, now in an era of artificial intelligence, how easy is this? It's going to be very easily achievable, isn't it? Now, that's the power of technology. Now, there is a lot, this hasn't happened yet, but it will happen very soon. There are drug companies, as you know, like Novo Nordisk, who has produced these weight loss injections like semaglutide and called Ozempic, which is now widely prevalent in Europe and America. I'm sure it will come to India very soon. Currently, I think there are tablets. This is also used to treat diabetes. Currently in tablet form, it's available in India, and it will come. The long-term complications of this drug and injection, we don't know. It's very new, but it's quite helpful in obesity. And such studies, if we want to understand, let us say this drug, how it is impacting the different categories of obese people, that understanding will open up an entirely new avenue for us. So that's the power of AI and personalized medicine. Please stop me if you want to ask any questions. So the second thing I wanted to talk about is genomics and pharmacogenomics. Now, what is genomics is understanding the genetic makeup of a human body. It's a huge, every cell has like a 1 meter or even more than long DNA condensed into it. Then you can imagine how much of DNA we need to learn about. Now, where I worked at King's College Hospital, there was a project called 100,000 Genome Project. This was funded by the government to big hospitals in London and in the UK to learn about rare disorders and diseases and what is the genetic makeup of these patients. There were 100,000 patients who, I think 10,000 patients, 75,000 patients participated. And this project is complete. And I remember the professor of where I trained, he was a part of this. And what this involves is gene sequencing, which probably would have taken, time for those machines to analyze. And there are so much of, innovation have come up in gene sequencing currently. And I'm truly fascinated to see what this will open up in future. And the same way to the drug companies. You must see, many times in the medical world, we hear about doctors and the hospitals who contribute to the drug development. But I must say, the true innovators in medical world are the pharmacy companies. Some of them are fantastic. For example, the golden bullet I discussed about was invented by a drug company called Novartis. In fact, the CEO of this company is an Indian. And they have some fantastic innovations in the field of hematology. The same way, there will be more, newer things coming up in this field, what's called as pharmacogenomics, which means the way we metabolize drug is also very variable. Even for paracetamol, dosing is very different in India and in Europe. In Europe, people take like 2 paracetamol, which is 1 gram. In India, you will see this intermediate dosing of paracetamol at 650 milligrams rather than 500 milligram tablets. So that's because paracetamol, a higher dosing is required for Europeans when compared to Indians. So we all metabolize drugs in different way. And understanding this also, there are varieties of technology has come up currently to help us understand this in a better way. Then we can choose the right dosing, the right type of treatment for people. And this is a part of precision personalized medicine as well. Thirdly, many of you might already have gone through this. I don't know, because you have had 5 days of training. That's a lot. And but I thought without this, this topic won't be complete. AI-powered diagnostics. Now, the diagnostic companies, they are all overjoyed and overthrilled with this newer technologies coming up. Every one of them is working. For example, where in hematology, we report blood films, which means we spread the blood on a slide, and then we put it under the microscope and we analyze for varieties of disorders. I have to say, I still remember the day when I first looked at what is called as a spherocyte. Spherocyte is the red blood cells become so round. Red blood cells have to be flat and biconcave so that they can squeeze through blood vessels and spleen, and so that they could keep circulating to make them pliable. There is a condition called hereditary spherocytosis, where the red blood cells lose this plasticity and become like a balloon, and making them hard to squeeze through spleen, and then they die in spleen. Then that causes anemia. That's spherocyte. I still remember the day like 20 years ago when I looked into the microscope, and I was super excited to see, wow, I could see the spherocyte now. Now in future, probably, we don't have to worry too much. I think it's the AI and technology is taking care of it. Maybe humans will join them to double check. Having said this, the precision is much better, probably with the technology and AI as well, because I read an article recently saying that in breast cancer patients, they are having, mammograms, which is the X-ray of the breast, and they look at the cancer appearance. And it said that AI has actually found out 5 cases that was not able to even predict by the experienced radiologists who were reporting those mammograms. So certainly the accuracy in detecting breast cancer is very high when we combine along with the AI algorithms. Same way with CT scans, MRIs, and any cancer biopsy slides. These things are coming up. And if you ask me, are they already available? No, they are not. Especially in hematology, they haven't come yet. But I know in research, big hospitals in London, this mammogram breast cancer detection is already coming there. So yes, in diagnostics, the earlier we detect anything, especially when it comes to cancer like breast cancer, prostate cancer, these cancers are completely curable if we diagnose them at an earlier stage. Now, while talking about this, I want to take the opportunity to remind, I'm sure you all are of, I don't know if you're young students or professors. If you're in your 40s and 50s, please be aware that having regular screening for cancer, like especially for breast cancer for women and prostate cancer in men, can be treated completely if diagnosed early. So please make sure you go for those tests. In health, more than technology, more than anything, as I always say, prevention and early detection is very important. Early detection and prevention can happen with only health awareness. Only when you learn about what is available for you and what you should do to take care of your health. So please go for the cancer screening in whatever form, and colonoscopy is usually available later 60s. Colonoscopy is to diagnose colon cancer, and making those lifestyle changes, especially in India. I'll tell you it interestingly. I visit India twice or thrice a year, and I have seen the increased food ordering from outside, even when compared to Europe. I think it's that Swiggy or those online platforms, the food delivery platforms. Be mindful of what you eat. We are what we eat. There's no doubt about it. Your food affects your mental health. Your food affects your physical health. Your food is the main determiner of whether you will have heart attack or stroke. Your food is the main thing to say whether you will get cancer eventually. Not all the cancers, majority of the cancers. And your gut health. Gut health means the microbes in your bowel. There are recently studies that have come up that there is a significant relationship between your gut health and Alzheimer's dementia. Dementia is something that happens when you're old. You become more forgetful. I mean, some of you in your family members with an elderly parents might come across Alzheimer's dementia. They say that reduced fiber content in our food is one of the major contributors for developing dementia. So please be mindful of what you eat. And I will, if I have time, I will talk a little bit about the lifestyle changes that we all in our 40s, especially young age. Your body will cope when you're in your 20s. I don't know whom I am presenting to. If you're in your 20s, I'm not saying don't follow any healthy, but your body will cope. But if you're reaching late 30s, 40s, 50s, becoming more mindful of what you eat, what you do, and what are those things available for you, so that you can prevent some disastrous diseases happening, is very important. Now, going to any questions? Should I wait? Okay, I hear silence, so I'll carry on with my next slide. Now, the next one is, which we almost discussed, is AI for risk prediction. So what does this mean? Which we were discussing. How many of us, if you are a diabetic and listening to this talk, and then if we want to know, let us say I want to know what is my risk of developing a retinal problem, eye problem, a kidney problem, or a heart disease, or a stroke with this diabetes. We do have risk factor calculations at the moment, but not in an in-depth understanding way. But having said this, let us say we in England, we have electronic health records of patients over many, many years. Let us say if we are able to collect the age, blood pressure, cholesterol level, family history, your diet history, or your comorbidities, and then use AI to analyze. That's the power of AI, data analysis. I'm sure you all know better than me. The robust data analysis, the simplicity with which it can handle and tell us what's what is the power of using here. Okay, and very soon we will have better risk assessment tools, especially in metabolic disorders. By metabolic disorders, I mean the obesity, diabetes, and cholesterol, and the risk of developing heart attack and stroke. Now, I'm not talking about bigger diseases here, because I will tell you all, 25% death in India, over 25% of deaths in India is due to coronary heart disease, which is preventable if we all take those precautions. And with AI algorithms, I'm sure we will have a better understanding of where our risk is, whether we are low risk or high risk or no risk. That's the championship. So yes, preventive medicine, proactive interventions is something that's going to be very, interesting and fascinating in future with AI. What's next? And AI in drug discovery and development, which also I talked to you about, but how it can analyze, help assist in drug companies developing drugs. I don't know how many of you know how a drug is invented. It's a very beautiful process, okay? Drug invention is a very interesting thing. For example, in cancer, let's say we found out this cellular pathway that causes cancer. For example, the Philadelphia chromosome, the translocation from chromosome 9 to 22 that causes chronic myeloid leukemia is expressed as a protein on a cell. Now, we need to invent a particle that will exactly go and attach to that Philadelphia chromosome expression that will activate that or deactivate that so that we cure that disease. So those different shapes of the drug, usually drug companies sit and work on it. Now with AI, that's an amazing thing. AI assists the drug companies in designing these structures that can fit these proteins well. It simplifies the job. So the drug discoveries are much more quicker. Not only that, let us say we have invented a drug. Okay. Now, once you invent, that drug cannot come into the market immediately, because you don't know what kind of effect it will have on your body. Every drug that we take in allopathy, the modern medicine, has side effects. There is a book called National Formulary. Usually here it's British National Formulary. I'm sure in India there will be a pharmacopoeia. You go through it. Every drug, including paracetamol, will have side effects. This is what we need to establish before you release that drug. So every drug goes through what is called as a clinical trial. It's tested on a small number of group, and then a bigger number of group, and then a more wider representative of the public. And then it has to go through rigorous regulatory checks before it comes into the market. Sometimes after coming into the market as well, it is released on a trial basis for the doctors to use and report back, and then only it will be widely available. Now, this process before, let us say in clinical trial 1, we collect the data in varieties of ways. For example, how it impacts the kidneys, how it impacts the liver, what kind of side effects you see in the metabolism. These data analysis is hugely can be, simplified using AI. So a drug that sometimes takes years before it reaches the market can reach within a year or 2. So AI has a role in every field of medicine. Now, before we go into this, I don't know if you all we talked about giving a break. Should we take that break now? Let me. Do you all want to take a break and then we join in, I don't know, maybe 10 minutes? So, Sudha, is that the right thing to do? I want to know, or do you want me to continue?
Okay, ma'am. If you have any videos, you can play now. Then after that, 5 minutes. Then we'll start the next one.
Okay, I don't have a video.
Okay, ma'am.
Sorry about that. But we
Okay,
can
okay.
take a break. It's 1:15 here.
Okay.
I'll join in around another 5 minutes. If you all want to have a
Okay.
cup of water or tea and
Yes, ma'am.
join back in 5 minutes.
Okay,
Thank
ma'am.
you.
Okay. Thank you. Thank you.